Hello, in this lecture we'll find out the area of a circle using two different methods. In the drawing we have a circle and we also have here square ABCD, and you know that this is line segment AP that equals to 1 unit in its length. This is line segment QC that equals to 3 units. Again, our mission is to find out the area of this circle. So first of all, we'll define the center of this circle. This point is point O. And you know that all the angles inside the square are right angles. So those 4 angles are all right angles. So this is a right angle. This is also a right angle. This is a right angle. And this is also a right angle. We define the point of tendency of this tangent AB with this circle. This point is point S. And we join points O and S together by a straight line. OS is of course the radius of the circle. We define the radius of the circle as x, so OS equals to x. We join points O and Q together by a straight line. OQ is also the radius of the circle that is equal to x according to our definition. So here we can implement rule 1. So I think quickly on rule 1. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle. We have also tangent AB that is tangent to this circle is point M. Point M is the point of tendency of tangent AB with this circle. In addition, we have the radius OM that equals to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever your radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to this rule, rule 1. So we can actually implement rule 1 in our drawing. Well, in our drawing, we have the radius OS that equals to x. The radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle. And whenever your radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we have the radius OQ is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever your radius is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. So by doing these constructions, we can do the quadrangle OSBQ. Inside quadrangle OSBQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4 missing angle, in total they must be equal to 360 degrees, according to the rule that states that the sum of the angles in any quadrangle is equal to 360 degrees. And therefore this 4 missing angle must be equal to 90 degrees in its size. So inside quadrangle OSBQ we have 4 right angles. And according to rule 5, any quadrangle that has 4 right angles must be equidistant rectangle, not a square. So in order to quadrangle OSBQ, it's a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle OSBQ, side OS must be equal to the opposite side BQ. But OS is x, therefore BQ must be also equal to x units in its length. Likewise, according to the same rule, in the same rectangle OSBQ, side OQ must be equal to the opposite side BS. But OQ is x, therefore BS must be also equal to x units in its length. So what we found out that this quadrangle OSBQ is not a rectangle but a square, why? Because of the fact that all of its sides are equal to each other. Each side of this square equals to x. Okay. We also know that all the sides of any square are equal to each other. So in square ABCD, we know that side AB equals to side BC. So I'll write it down. Side AB equals to side BC in square ABCD. AB equals to AS plus SB. So AB equals to AS plus SB. Plus, and we know that AB equals to BC. And BC equals to BQ plus QC. So, repeat again. So we know that in square ABCD, AB equals to BC. Okay? But AB equals to AS plus SB and BC equals to BQ plus QC. So what we found out that according to equation 1, AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is. Plus SB, SB equals to x. So AS plus SB equals to BQ. BQ is also x plus QC. It is given us in the question that QC equals to 3. So in total, according to equation 1, we actually found out that AS plus x equals to x plus 3. So here we subtract x from this equation, equation 1. So x will get cancelled. And we have to leave with AS is equals to 3 units in its length. So we actually found out that this line segment AS equals to 3 units in its length. In the next step, we will do a construction. That is to say, from this point P, we will draw perpendicular on SO. Again, from point P, we will draw perpendicular on SO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point P and SO. This point is point N. By doing this construction, we can derive the small quadrilateral AP and S. Inside the small quadrilateral AP and S, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle. In total, they must be equal to 360 degrees, according to the rule that says then the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this 450 degrees must be equal to 90 degrees in its size. So inside quadrilateral APSN, we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will let quadrilateral APSN as a rectangle, because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle APSN, side AP must be equal to the opposite side SN, but AP is 1, therefore SN must be also equal to 1. Likewise, according to the same rule, in the same rectangle APNS, side AS equals to the opposite side PN, but AS is 3, therefore PN must be also equal to 3 units in its length. What is the length of the missing line segment NO? From the drawing it is very easy to see that NO equals to SO minus SN. Again, NO equals to SO minus SN. So NO equals to SO, that is X, it is the radius of the circle, that is X, minus SN, that is 1. So in total, NO equals to X minus 1 units in its length. In the next step, we'll join points A and O, we'll join points P and O together by side line. Yeah, we'll join points P and O together by side line. Point O point O is the center of the circle, point P is the point of the circle itself. Therefore, OP is the radius of the circle, is equal to X according to our definition. So, in the next step, we'll copy the right angle PON in a new page, and we'll implement the Pythagoras theorem on this right angle, triangle PON. According to the Pythagoras theorem, in any right angle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right angle PON that I copied from the original drawing. According to the Pythagoras theorem, this right angle PON, PO squared, that is the square of the hypotenuse, is equal to PN squared plus NO squared. Again, PO squared equals to PN squared plus NO squared. So I write it down. PO squared equals to PN squared plus NO squared. The hypotenuse PO equals to X, therefore PO squared is X squared, and it is equals to PN squared. PN is 3, therefore PN squared is 3 squared, that is 9, plus NO squared. NO is X minus 1, therefore NO squared is X minus 1 squared. So in total, I shall find out that X squared equals to 9 plus X minus 1 squared. Here we'll open the brackets on this side of this equation, and we get that x squared equals to 9 plus x minus 1 squared. X minus 1 squared equals to x squared plus 1 squared, that is 1, minus 2 times x times 1, that is minus 2x. So here we have x squared on both sides of this equation, so x squared will get cancelled. After we cancel x squared, in the side of the equation we left with nothing, that is to say 0. On the other side of the equation we have 9 plus 1, that is 10, minus 2x. So in total, if we found out that 0 equals to 10 minus 2x. Here we add 2x to this equation, and we get that 2x equals to 10. Here we divide this equation by 2, and finally get that x, that is the length of the hypotenuse, and x, it is also the radius of the circle, is equal to 10 over 2, that is 5. Okay, again, if we found out that the radius x of this circle is equal to 5 units in its length. Our mission is to find out the area of the circle. Actually, the area of any circle is equal to pi times the radius of the circle squared. And therefore, the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is x, therefore the radius squared is x squared. So in total, we should find out that the radius of our circle is pi x squared. X is 5, therefore x squared is 5 squared, that is 25. So in total, we should find out the area of our circle, that is the area that we are looking for in this question. It is equal to either 25 pi square units, so in terms of numbers, it is equal to 78.54 square units. That is the answer to the question. Repeat again. If we found out that the radius of this circle equals to either 25 pi square units, so in terms of numbers, it is equal to 78.54 square units. So we finish with the first method. In the next step, we find out the radius of the circle according to the second method. So we know that all the angles inside square ABCD are right angles, so this is a right angle, this is also a right angle, this is a right angle, and finally this is also a right angle. We define the center of the circle. This point is point O. We define the point of tendency of tangent AB with this circle. This point is point S. So here we have the common extent point B. From this common extent point B, we have two tangents to this circle, tangent BQ and tangent BS. And according to rule 2, they are equal to each other. So I'll click quickly on rule 2. The lengths of two tangents from a common extent point to a circle are equal. So in the drawing we have a circle, and this is the common extent point P. From this common extent point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. This is to say PA equals to PB. So we can actually implement rule 2 in our drawing. Why? Because in our drawing we have the common extent point B. From this common extent point B, we have two tangents to this circle, tangent BS and tangent BQ. And according to rule 2, they are equal to each other. That is to say, BS equals to BQ. So if we define the length of this tangent BS as x, then the length of this tangent BQ must be also equal to x because they are equal to each other in their lengths according to rule 2. Okay. We also know that all the sides of square ABCD are equal to each other. That is to say, AB equals to BC equals to CD equals to DA. So we know that AB equals to BC. So I write it down. In square ABCD, side AB is equal to side CD. So actually we have here, if we focus on this common extent point A, from this common extent point A, we have tangent AS, that is tangent from this second point S. From the same common extent point A, we have this line segment AD. We'll extend line segment AD until it touches the circle, and we'll define the touching point of the extended line segment AD with this circle. This point is point N. So from this common extent point A, we have tangent AS, and we also have here chord PM to the chord of this circle. Actually, for that reason, we can implement here rule 10. So, repeat rule 10. According to rule 10, in any circle, rule 10 is true in any circle, AB is a chord inside this circle, and we know that PT is tangent to the circle at point T. So, in this drawing, the following equation will be true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. We can definitely implement rule 10 in our drawing. Why? If we focus on this common extent point A, on this common extent point A, we have tangent AS, and also have from the same common extent point A, we have here chord PM. So all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, AS square equals to AP times AM. Again, AS square equals to AP times AM. So I write it down. So according to rule 10, if we focus on the common extent point A, AS square equals to AP times AM. So repeat again. If you focus on this common example point A, only to obtain AS square equals to AP times AM. Repeat again. According to obtain, if you focus on the common example point A, AS square equals to AP times AM. But before that, actually, I showed you that in square ABCD, side AB equals to side BC, side AB equals to AS plus SB, and side BC equals to BQ plus QC. Look it again. In square ABCD, side AB equals to side CD, and side AB equals to AS plus SB, and side AB equals to side BC. Side BC equals to BQ plus QC. So in total, according to equation 1, we actually found out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is. Plus SB equals to X. And it is equals to BQ also equals to X. Plus QC equals to 3. So in total, according to equation 1, we actually found out that AS plus X equals to X plus 3. So here we subtract X from the equation 1. So X will get cancelled. And we're left only with AS is equals to 3 units in its length. So this length with AS equals to 3 units in its length. So write it down. AS equals to 3 units in its length. According to rule 10, we only found out that AS square equals to AP times AM. Again, according to rule 10, AS square equals to AP times AM. AS is 3, therefore AS squared is 3 squared, that is 9. And it equals to AP. AP is 1 times AM. AM equals to AP plus PM. So in total, we actually found out that nine equals to 1 times AP plus PM. AP is 1, so in total 9 equals to AP is 1 plus PM. So if we found out that 9 equals to 1 plus PM, here we subtract 1 from this equation, and you get that PM equals to 9 minus 1, that is 8. So PM equals to 8 units in its length. That is to say, the length of this chord called PM is equal to 8 units. Okay? In the next step, we will do a construction. That is to say, from this point O, that is the center of the circle, will draw perpendicular on chord PM. Again, from point O, we'll draw perpendicular on chord PM. Circling, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We'll define the touching point of the perpendicular from point O and PM. This point is point N. So from the center of the circle, that is to say from point O, we have perpendicular on chord PM. Again, from the center of the circle, that is point O, we draw perpendicular on chord PM. Therefore, we can implement here rule 11. So, implementing on rule 11, according to rule 11, the perpendicular to a chord drawn from the center of the circle bisect the chord. So in the drawing we have a circle. This is chord AB. From point O, that is the center of the circle, we have here perpendicular ON. Again, from point O, that is the center of the circle, we have perpendicular ON. This is this angle equals to 90 degrees, and this angle equals to 90 degrees, according to our construction. So whenever you draw a perpendicular from the center of the circle towards any chord, it will bisect the chord. That is to say, perpendicular OM bisects chord AB. Perpendicular OM bisects chord AB, it means that AM equals to MB. Okay? So whenever you have a perpendicular that is drawn from the center of a circle towards any chord, the perpendicular also bisects the chord. Here, perpendicular OM, that is one from point O, that is the center of the circle, bisects chord AB. That is to say, AM equals to MB. So we can definitely implement rule 11 in our drawing. Why? Because in our drawing, we have perpendicular ON, that is one from point O, that is the center of the circle, and according, so we have perpendicular ON on chord PM. Again, we have perpendicular ON on chord PM. And according to rule 11, perpendicular ON bisects chord PM. That is to say, PN equals to NM. PN equals to NM. So, already know, according to rule 11, PN equals to NM. PN equals to NM. And chord PM has been bisected by perpendicular ON. That is to say, each half of chord PM equals to PM over 2. The first half is PM over 2. That is to say, PN equals to PM over 2, and NM also equals to PM over 2. So, the first half is PN, and it is of course equals to the second half. Each half equals to PM over 2. Because chord PM has been bisected by perpendicular ON. So each half of chord PN equals to PN over 2, of course. So today, according to rule 11, we found out that PN equals to NM equals to PM over 2. But we already found out that PM equals to 8. So PM equals to 8. So PM equals to 8. So this expression equals to 8 over 2, that is 4. So in total we should find out that Pn equals to 4. Pn equals to 4 units in its length. So okay, this is 97 Pn is equals to 4 units in its length. So in total An equals to 1 plus 4, that is 5. So in the next step we join points O and S together by straight line. Point S is the point of tendency of tangent AB with this circle. Point O is the center of the circle, point S is the point of the circle itself, therefore OS is the radius of the circle. We define the radius of the circle is the radius of the circle. OS is the radius of the circle, and according to rule 1, because of the fact that the radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle, therefore tangent AB will be perpendicular to the radius SO. If AB is perpendicular to the radius SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So inside quadrilateral ANOS we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle. In total they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral ANOS we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be at least a left angle plus a square. So we will go to quadrilateral ANOS as a left angle because it has 4 right angles. But we also know that the opposite sides of a left angle are equal to each other. So in left angle ANOS, side AN must be equal to the opposite side OS. But AN in total equals to 1 plus 4, that is 5. Again, AN equals to 1 plus 4, that is 5. Therefore, OS must be also equal to 5 units in its length. But OS is the radius of the circle. That is to say, the radius of the circle equals to 5 units in its length. Our mission is to find out the area of the circle. So actually we know that the area of any circle is equal to pi times the radius of the circle squared. Therefore, the area of our circle must be equal to pi times the radius of our circle squared. So it is pi, the radius of our circle is 5, and the radius squared is 5 squared. 5 squared is 25. So in total, if we found out the area of this circle equals to either 25 pi square units, or in terms of numbers, the area of this circle equals to 78.54 square units, and that is the answer to the question. So actually, in both methods, we found out that the radius of this circle is equal to either 25 pi square units, or in terms of numbers, it is equal to 78.54 square units. So in the next step, I will summarize the lecture. We'll start with the first question, of course. We'll start with the first method. So in this lecture, we found out the area of this circle using two different methods. In the first method, so first of all, in the drawing we have a circle, and we have also here square ABCD. In addition, we know that this is line 7 AP, that is equals to 1 unit in its length. This is line 7 QC, that is equals to 4 units in its length. Again, our mission is to find out the area of the circle. So, first of all, we define the center of the circle. This point is point O. We define the point of tendency of tangent AB with this circle. This point is point S. We define the radius of this circle as x. We join points O and S together by a straight line. OS is the radius of the circle, that is equals to x. We have the radius OS, that is on to point S, that is the point of tendency of tangent AB with this circle. Whenever you have a radius that is on to the point of tendency, then tangent AB will be perpendicular to the radius SO according to rule 1. If AB is perpendicular to SO, it means that this circle equals to 90 degrees, and this circle also equals to 90 degrees according to rule 1. Likewise, we join points O and Q together by straight line. OQ is the radius of the circle, that is equal to x. Again, the radius OQ is on to point Q. And therefore, according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. We also know that all the four angles inside square ABCD are right angles. So those four angles are all right angles. So inside quadrilateral SBQO, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees. According to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. So therefore this fourth missing angle must be equal to 90 degrees in size. So inside quadrilateral OSBQ, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be intersected and not a square. So we learn to quadrilateral OSBQ is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle OSBQ, side OQ must be equal to the opposite side SB. But OQ is x, therefore SB is also x, must be also equal to x. Likewise, according to the symbol, in the same rectangle OSBQ, side OS must be equal to the opposite side BQ. But OS is x, therefore BQ must be also equal to x. So if you found out that quadrilateral OSBQ is not a rectangle but a square, because all of its sides are equal to each other. Okay. In the next step, we did a construction. That is to say, from this point P, we draw perpendicular on SO. Again, from point P, this point P, we draw perpendicular on the radius SO. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and SO. This point is point N. Okay. So by doing this construction, we can delete the small quadrilateral AP and S. Inside the small quadrilateral AP and S, we have 1, 2, 3 right angles. This angle equals to 90 degrees because ABCD is a square. This angle equals to 90 degrees according to rule 1, and this angle equals to 90 degrees according to our construction. So in total, inside quadrilateral AS and P, we have 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this fourth missing angle must be equal to 90 degrees in size. So inside the small quadrilateral AP and S, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this rectangle, not a square. So we relate to the small quadrangle AP and S is rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle AP and S, side AP must be equal to the opposite side and S. But AP is 1, therefore and S must be also equal to 1 unit in its length. Likewise, according to the sum rule in the sum of rectangle AP and S, side PN must be equal to the opposite side AS. But AS equals to 3, therefore PN must be also equal to 3 units in its length. What is the length of the missing line segment NO? From the drawing it is very easy to see that NO equals to SO minus SN. Again, NO equals to SO minus SN. So NO equals to SO, that is X, it is the radius of the circle, that is X, minus SN, that is 1. So in total, NO equals to X minus 1 units in its length. In the next step, we join points P and O together by straight line. PO is the radius of the circle that is equal to X. In the next step, by copying the right triangle P and O in the equation, we implemented the Pythagoras theorem, this right triangle P and O. So actually, this is the right triangle P and O that occurs from the original drawing. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of this right triangle P and O is PO, therefore the square of the hypotenuse is PO square, and PO square must be equal to PN square plus NO square. PO is X, therefore PO square is X square, and it is equal to PN square. PN is 3, therefore PN square is 3 squared, that is 9, plus NO square. NO is X minus 1, therefore NO square is X minus 1 square. So in total, according to the Pythagoras theorem, we found out that X square equals to 9 plus X minus 1, 9 plus X minus 1 square. Open the brackets of this expression and find out that X squared equals to 9 plus X minus 1 squared. X minus 1 squared equals to X squared plus 1 squared, that is 1, minus 2 times X times 1, that is minus 2X. We have X squared on both sides of the equation, so X squared will get cancelled. In this side of the equation, we left with nothing, that is to say 0. On the other side of the equation, we left with 9 plus 1, that is 10, plus 2X. So in total, according to this equation, we should find out that 0 equals to 10 minus 2X. We added 2X to this equation, and when we found out that 2X equals to 10, here we divided this equation by 2, and finally found out that X equals to 10 over 2, that is 5. So we found out that the radius X of this circle equals to 5 units in its length. Our mission is to find out the area of this circle. Actually, the area of any circle equals to pi times the radius of the circle squared. So repeat again, the area of any circle equals to pi times the radius of the circle squared. Therefore, the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is x, therefore the radius squared is x squared. So in total, the area of our circle must be equal to pi x squared. But x is 5, therefore x squared is pi squared, that is 25. So in total, the area of this circle equals to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. We finish with the first method. In the next step, I showed you actually how to find out the area of this circle according to the second method. So first of all, ABCD is the square, therefore all those 4 angles are right angles. And we also know that in any square all the sides are equal to each other. So in square ABCD, side AB equals to side BC. But before that, If we focus on this common standpoint point B, from this common standpoint point B, we have two tangents to this section, tangent BS and tangent BQ. And according to rule 2, they are equal to each other. That is to say, BS equals to BQ. So if you define the length of tangent BS as x, then the length of tangent BQ must be also equal to x because they are equal to each other according to rule 2. So BS equals to x and BQ also equals to x. Then we know that all the sides of any square are equal to each other. So side AB equals to side BC. So in square ABCD, side AB equals to side CD. AB equals to AS plus SB. Again, AB equals to AS plus SB, and BC equals to BQ plus QC. Again, BC equals to BQ plus QC. So in total, according to equation 1, AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is, plus SB, SB is X, and it is equals to BQ, BQ is also X, plus QC, QC is 3. So in total, we found out that according to equation 1, AS plus X equals to X plus 3. AS plus X equals to X plus 3. Here we subtract X from this equation 1, we finally found out that AS equals to 3. So this is line segment AS, that is equals to 3 in its length. If you focus on this common exam point A, from this common exam point A, we have tangent AS, that is tangent to the second point S. And here we have line segment AD. We extended line segment AD by a straight line until it touches the second, and we find the touching point of the extended line segment AD with this second. This point is point M. So from the same common exam point A, we have tangent AS, and from the same common exam point A, we have here chord PM. So all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. So I'll repeat quickly on rule 10. According to rule 10, rule 10 is drawn in any circle. So in any circle, if AB is a chord, and we have, from the common standpoint point P, we have tangent PT, and from the same common standpoint point P, we have here chord AB. So in this drawing, the following equation is true, that PT squared equals to PA times PB. Again, PT squared equals to PA times PB. So we can implement rule 10 in our drawing. Why? Because in our drawing, if you focus on the common standpoint point A, from the common standpoint point A, we have tangent AS, and we also have here from the same common standpoint point A, we have tangent chord PM. So all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, AS square equals to AP times AM. Again, AS square equals to AP times AM. So again, according to rule 10, if we focus on this common standpoint point A, according to rule 10, AS square equals to AP times AM. AP is 1, AP is 1, and AM equals to AP plus PM. Again, AM total equals to AP plus PM. AP is 1 and AM equals to AP plus PM. So in total 9 equals to 1 times AP plus PM. So 9 equals to 1, AP is 1 plus PM. So in total we found out that 9 equals to 1 plus PM. Here we subtracted 1 from this equation, and we found out that PM equals to 9 minus 1, that is 8. Here PM equals to 8 units in its length. That is to say, chord PM in the circle is equal to 8 units in its length. In the next step, we did a construction. This is to say from this point O, that is the center of the circle, we do perpendicular on chord PM. Again, from point O, that is the center of the circle, we do perpendicular on chord PM. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and PM. This point is point N. So we have perpendicular ON from the center of the circle on chord PM. And therefore we can implement here rule 11. So I click on rule 11. According to rule 11, the perpendicular to a chord drawn from the center of the circle bisect the chord. So in the drawing we have a circle, point O is the center of the circle. From point O we have here perpendicular OM on chord AB. Again, we have perpendicular OM, that is from the center of the circle, on chord AB. And whenever you have a perpendicular from the center of the circle on any chord, it will bisect the chord. Therefore, perpendicular OM bisects chord AB. That is to say, AM equals to MB. Okay, so we can implement rule 11 in our drawing. In our drawing, we have perpendicular ON, that is one from point O, that is the center of the circle. We have perpendicular ON on chord PN. Therefore, all the requirements of rule 11 are satisfied, and therefore we can implement a rule 11. According to rule 11, perpendicular ON bisects chord PM. If ON bisects chord PM, it means that PN equals to NM equals to PM over 2. Okay? According to rule 11, perpendicular ON, that is one from point O, that is the center of the circle, bisect chord PM. That is to say, PN equals to NM equals to PM over 2. Again, PN equals to NM equals to PM over 2. But PM is 8, therefore PM over 8 is 8 over 2, that is 4. So in total we shall find out that PN equals to 4. From this equation, we derive that PN equals to 4. This is 97 PN, that equals to 4 units in its length. So in total, AN equals to 1 plus 4, that is 5. AN equals to 5 units in its length. In the next step, we join points O and S together by straight line. OS is the radius of the circle. The radius OS is drawn to point S, that is the point of tendency of tangent AB. With this circle, whenever radius is drawn to the point of tendency, then tangent AB will be perpendicular to the radius of SO. So if AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So inside quadrilateral ANOS, we have 1, 2, 3 at angles. This angle equals to 90 degrees according to our construction. This angle equals to 90 degrees because ABCD is a square. And this angle equals to 90 degrees according to rule 1. So in total, inside quadrilateral OSAN, we have 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4th facing angle, in total they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this 4th facing angle must be equal to 90 degrees in size. So inside quadrilateral OSAN, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this rectangle, not a square. So we look for the other OS again. It's a rectangle because it has 4 rectangles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle AN OS, side AN must be equal to the opposite side OS. But AN equals to 4 plus 1, that is 5. Therefore OS equals to 5 units in its length. But OS is the radius. That is to say, the radius of the circle equals to 5 units in its length. Okay. Our mission is to find out the area of the circle. We know that the area of any circle equals to pi times the radius of the circle squared. Therefore, the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is 5, therefore the radius squared is 5 squared, that is 25. So in total we can find out that the radius of our circle is equal to either 25 pi square units, or in terms of numbers it is equal to 78.54 square units. So in both methods we can find out that the radius of this circle is equal to either 25 pi square units, so in terms of numbers the radius of this circle equals to 78.54 square units. Okay, thank you very much.